Now we're going to talk about the difference between state and path functions. A state function is a property of a system that depends only on the state of a system. What this means is that a state function, it only depends on how the system exists at the moment we're measuring the value of the state function. So for example, the mass of a bowling ball is a state function because the mass depends only on how much matter is in the bowling ball at the time we measure it. It doesn't matter how the bowling ball was made or how the bowling ball got the mass that it has. It simply depends on how much matter is in the bowling ball at that moment. Conversely, a path function is a property of a system that depends on the path by which the system achieved a particular state. So for example, the time it took to make the bowling ball could be a path function. Because if we are, let's say, we have a factory that makes bowling balls very efficiently, that way of making a bowling ball could lower the time compared to sculpting it by hand. So time is often an example given for a path function because the amount of time it takes to do something depends on how you do it. All right, so we're going to look at kind of a classic example of the difference between state and path functions, and we're going to pretend that we have a mountain here, okay? And we want to climb this mountain. Now, one way we can climb the mountain is simply by running to the top. So we've got a little guy down here, and he's going to run up the path of some conceived path of this mountain to get to the peak of the mountain. And another way we can possibly get to the top of the mountain is if we have a giant trampoline, right? I mean, if you have a giant trampoline, you can simply jump to the top of the mountain. So there are two ways by which we can get to the mountain, by running or by jumping on our giant trampoline. Both will get us to the top of the mountain. Now, the distance we travel is going to depend on how we get to the top of the mountain. Either we can run, let's say, around the mountain to get to the top, or we can jump directly up to the top. So that's going to be the distance we travel. It's going to depend on by what mode we get to the top of the mountain. But the overall change in height from the base of the mountain to the tip of the mountain is going to be the same, regardless of which path we take. Therefore, the displacement, or the net change in altitude, is not dependent upon the path we take. It's going to be the same regardless, right? We're going from the very bottom of the mountain to the very top of the mountain in both cases. So our displacement is constant regardless of the path we take. But our distance traveled is going to depend on the path we take. Therefore, distance is a path function, and displacement is a state function. All right, so to recap, a state function depends only on the current state of the system. So in this case, our system would be probably the runner in the mountain. So the state we're concerned with is the height of the mountain. That's what's going to determine the displacement. The distance traveled is going to be determined by how the traveler gets to the top of the mountain. Therefore, it will be a path function because it does depend on the path taken.